So this video is for our titration that we're going to be doing here. So this is all background information. You can read that. I do want to point out this graph. You're going to be doing titrations. One indication that the titration is over is you can see an analyze button turn blue. Uh, but for the other titrations that we do, you're going to need to wait until you see the curve taper off like this, right? We have to get it past the endpoint. It doesn't need to go way out here, but stop the reaction once you see the reaction get to a point right about here, then you're okay to stop the reaction and analyze it. So just more background information here. You can read through all of that. And we're just gonna kind of get into here so I can kind of give you an overview here. So a lot of materials up here. The electrode, we bring down an electrode. Uh, get a, now, I already have that. Doesn't hurt to have another one. And I think we're good. All right. So we're gonna put about 45 milliliters of water into the flask here. Right. So we're just use the slide button. It doesn't have to be exactly 45, 46, 40, 44. It's going to be okay. And then we'll move that other way. Then we'd have to put our pH probe in here. And notice that once I put it in there, it starts reading the pH of it over here. Let me just move it off to this side here, right? 7 here. So now we're going to put some KHP reagent in there. So I need my scupula. Tear that out. And notice it says 0.2 grams. So please do not put 2 grams of this. The 0.1 button. Here's 1. Here's 2. Make sure I see the cursor. Hit it a couple times and I've recorded that value. And here's it. So we never, yeah, there's information down here. We can scroll down and this is going to show the graph for our titration curve. So we're going to take this and we're going to just dump it in here. And notice, let me put this in the trash. Notice that the pH came down 3.55-ish, right? Then we're just going to go ahead and start the titration. But notice here it starts to read. Um, Depending on your computer and how new or old it is, right? This could take 3 minutes. It could also take up to 45 minutes to an hour, right? I've seen it go that long. So please just be prepared. Let the reaction finish. This titration, the first titration, you're gonna be able to hit the analyze button. It's gonna turn blue. You'll know when the titration is over. But for the next ones, uh, I'll show you that you're going to have to interpret it yourself, and I'll let you know how to do that. So I'm gonna pause this, let the reaction run because it is gonna take a few minutes. Now you'll see the titration curve here, and we'll see the analyze button here, and it's going to measure the inflection point, right? Which should be right in the middle of this almost vertical line. And it gives us 6.38. So 6.38, 6.25, this is 6.4-ish over here. So 6.38 is right in the middle, right here. So 6.38, and that's where we're just going to go ahead and input. Now, you're going to repeat this process for the next two. What we're doing is we're just kind of standardizing this. We want to, if we do this 3 times, we'll get a really good average for the KHP that we see here. But when you run the next two, notice there's no blue analyze button. Is that you're going to have to take your best guess as to what that inflection point is. So if we go back to the previous one, I believe it's still there. Oh, the inflection point is not showing anymore. but we can look at something previous right there, this endpoint right here. So you're going to move your cursor. It's going to give you a value up here. It's going to give you a value down there. Just make your best guess as to what that inflection point is. I believe you could probably go to two decimal places, I believe. Yeah, let's do two decimal places. But your best guess as to what that inflection point there is going to be for that. So you're going to do that for the next two that you see there. And then you're going to run it on some hydrochloric acid. So for that one, you're going to need to use the pipette for that one there. So you put the pipette, just take it, put it into the beaker of HCl, but prepare it the same way. And when you answer that, you're going to do a third titration using the hydrochloric acid. And you're going to want to find that inflection point, right? And this is going to be on your x-axis for the milliliters of base used, the volume of the base used for the hydrochloric acid solution. Okay. Then we can get into our discussion where we do work on some calculations. So in order to determine the moles of it, uh, they provide for you some information here, right? So calculate the moles of KHP. You can take the grams of KHP, which was measured here. So for one, the first trial, we multiply that by, it says divide here, but take that divided by that value here, which is, I have mine, I use the reciprocal value, so that's why it looks a little bit different in mine, but you'll get the same answer regardless. But take the grams of it divided by 204.233, and you'll get your moles of KHP. And I would go with significant figures on that. Four significant figures because we see four here, uh, six here. So let's go our answer to four significant figures, and that'll determine. But then you're going to have to repeat that process because we need it for all three trials of the KHP. So you had three different masses, and that's going to give us the average moles that we used to do there, right? Uh, so we don't have to average these out. Whatever the mole for trial one is, you're going to use that for the concentration of in molarity of the base for that particular trial. So I know I have 6.53 here, right? So 6.53, but you need to use whatever value that you collected in particular. So here, the volume of base for trial one, 6.38. So that this would then be 6.38. But I don't think I'm going to leave it in there. I'm just going to put a question mark here so that we're not using these values in your calculations. But you're going to take the moles of KHP from trial one, divide it by the volume, excuse me, in milliliters. And then you're going to use this conversion factor to convert that into liters because that's what molarity is. Molarity is moles per liter. So we have to make that conversion there. And you're going to calculate number two and number three the exact same way so that you'll have all three concentrations. Now, these concentrations do have to be averaged. You're going to average those concentrations out. So add all three of them together. It equals on your calculator, then divide by three. Don't do it in one calculation. You will absolutely get a wrong answer on your calculator. So add them all together, then hit equals, then divide by three, and you'll get the average concentration. And the average concentration is going to be used this. For on part 16, we need that average concentration. So we're going to take the moles, in order to calculate the moles of base, we're going to use the volume, the volume of the base used for HCl multiplied by the molarity of the base, the average that was just previously calculated, and that will give you the moles of base. Whatever this moles of base is, it is equal to the number of moles of HCl that's present, right? So whatever this answer is for moles of base is identical to this value here for HCl when it reaches that equivalence point. Then we have to answer, why did you need to know? Why did you not need to know the exact volume of water present? Water is only used to dilute it. Water doesn't have any effect on the reaction between the acid and base. It's just there to dilute that solution. So we would click here, precise amount, has no effect on there, and we just use it to dilute it. Yeah, this will finish up the titration lab.